Dear learners, welcome you all to the lesson 2 of time, speed and distance. So again, I would just want to remind you the syllabus of the topic being your average speed, which is your lesson 1, uh, time and distance reference, which is your lesson 2, same distance questions as your lesson 3, trains as your lesson 4, boats and streams as your lesson 5 and races as your lesson 6. So let's get into the video, which is your lesson 2, that is your time and distance reference. So here I would just wanted to give you a scenario where let's say I'm going to start from my home at let's say 7 a.m. So I start from my home at 7 a.m. I'm taking a cycle. I wanted to reach one place where I travel at a speed of 10 kilometers per hour. But unfortunately, somewhere in the middle of my journey, my cycle went out of order. So I had to wait there for about 1 hour. I don't have any object or gadget with respect to the time. I only know that I started at 7 o'clock in the morning. My cycling speed is 10 kilometers per hour, and my cycle went out of order. So I'm waiting there for almost 1 hour, and then there's nobody to help me out. So I thought I might as well can carry my cycle all the way back home, and I can probably return. And my returning speed is 1 kilometer per hour, and by the time I reach home it is 2 o'clock. So let me sum up all the data. So I started at 7 o'clock in the morning. My cycling speed is 10 kilometers per hour. I had to reach a place, but my cycle went out of order somewhere in the in my journey. So I'm just waiting there for a help for almost 1 hour. Nobody came. So I took my cycle, carrying it all the way back home, and I came back at 2 p.m. My walking speed is 1 kilometer per hour. So the question here is, what would be the total distance that I had traveled? Okay, so you can just pause the video, think for a while, and just check your answers. Now I'm going to use a strategy. See the total time that I had taken. So here is where your concept comes in the picture. This is your time reference questions. Time reference question, because you have a data where you started at 7 o'clock in the morning and you came back at 2 p.m. So the total hours that I had spent outside is 7 to 8, 9, 10, 11, 12, 1 and 2. So totally it is 7 hours that I had spent outside, but 1 hour I waited here. So 1 hour I did not travel at all. So 7 minus 1, 6 hours. So this 6 hours is nothing else but the time taken for me to cycle and the time taken for me to walk. So this 6 hours is the total time for my journey. Okay, the 6 hours is the total time for my journey. So the time taken for me to cycle and the time taken for me to walk is the 6 hours. So from here, the question seems to be very simple, because your speed is given by distance by time taken and your time is given by distance by speed. So if you are going to take the time distance that you had traveled as just d divided by speed. Speed of cycling gives your time taken to cycle, so which is nothing else but again 10 plus d divided by 1, because I don't have to convert any unit. The total, time taken I'm taking as hours, and the speed is also in kilometers per hour, so I don't have any necessity to convert the data here. So post which, if you do your calculations, you can take this as, so here I can take as 10. So this is d plus 10d is 11d. 11d will be equal to 60. So my distance is 60 divided by 11. So my distance will be equal to 60 divided by 11. So I can take as 5 by 11 kilometers. So my total distance is again into 2. So 5 by 11 into 2 is going to be my answer. Or I can take 120 by 11, which is again so 120 by 11, or 5 by 2 to 11 always gives you 10 by 11, and this is the total, sorry, 10 by 11, and this is the total distance that I had traveled. So my total distance is going to be 10 by 11 kilometers. 10 by 11 kilometers. Okay, so let me just sum up. So here we took the time reference because we know that the girl has started at 7 o'clock in the morning and came back at 2 p.m. So the total hours that he had spent outside is 7 hours, out of which 1 hour went in for his. So the remaining 6 hours is nothing else but the time taken for her to travel by cycle and the time taken for her to walk. So taking a time reference, we had solved this. Moving to the next question. So here is your next question. The question says a thief steals a car at 2:30 p.m. and drives it at 60 kilometers per hour. The theft is discovered at 3 p.m. and the owner sets off in another car at 75 kilometers per hour. When will he overtake the thief? So let's again draw a diagram and see. See, I'll assume like this. So let's say here this is at 2:30. So at 2:30 the theft has happened and this guy is traveling at a speed of 60 kilometer per hour. That is, a thief is traveling at a speed of 60 kilometers per hour. So the theft is discovered at 3 o'clock. So at 3 o'clock the thief would have already covered 30 kilometers because his speed is 60 kilometers per hour, and at 3 o'clock, that is at, sorry, at 1 o'clock, 2:30 to 3, no, so only 30 minutes. So 30 minutes this guy would have traveled 60 kilometer. So now at 3, exactly at 3, so the thief is at this place and the police is at this place. So the police is 30 kilometers away from the point where the thief is at. So the time taken by the thief to travel from this point, let's say this is the point where the thief has, caught hold of the the police had caught hold of the thief. So the time taken by the thief to travel from this point to this point is nothing else but the time taken by the police to travel from this point till this point. So here again we are going for a time reference. So I repeat, at 3 o'clock the police is at this place, that is 30 kilometers away from the thief in the same direction, and the thief is at this point where he 30 kilometers is ahead of the police. So the time taken by the thief to travel from this point to this point, let's say this is x kilometers. Okay, so to cover x kilometers is nothing else but the time taken by the thief to travel x plus 30 kilometers. So since the time taken by the thief, I am taking as tt, will be equal to the time taken by the policeman, and as we know speed is distance by time, so your time is distance by speed. So the distance traveled by the thief is only x kilometers divided by and speed of the thief. So speed of the thief is 60, which will be equal to, this is 60, which will be equal to x plus 30, because the police had to travel another 30 kilometers, which the thief had already crossed, divided by speed of the police, which is 75 kilometers per hour. So on cross multiplying, you can directly get the answer. So either I can take here 15 as 4 and 15 as 5. So this is 5x will be equal to 4x plus 120. So your x is equal to 120 kilometers. Okay, so x is 120 kilometers. Now when will the thief be overtaken? So the question is, when will the thief be overtaken? Now as we know, this is 120 kilometers, here it is 120 kilometers. So the thief travels at a speed of 60 kilometers per hour. So from here to here, that is to cover a distance of 120 kilometers, he would take obviously 2 hours, which is from 3 p.m. it's 2 hours, so which is 5 p.m. And that is your answer. I repeat, so let's have a quick, brush up. Like the thief starts the car, he steals something and starts the car at 2:30 and drives it at 60 kilometers per hour. And the theft is discovered at 3 o'clock. So in the span of 30 minutes, he would have traveled 30 kilometers because his speed is 60 kilometers per hour. So let's take, this is a point where the thief overtakes, the policeman overtakes the thief, or the policeman caught hold of the thief, which is against x kilometers from this point, that is the point at 3 o'clock. So the time taken by the thief will be equal to the time taken by the policeman in order to cover this. So with the time reference, we are just solving this, a very simple calculation where it tells you it is 120 kilometers. So 120 kilometers to cover with a speed of 60 kilometers per hour from 3 p.m. is just 2 hours, which is again 5 p.m. and that's your answer. You can solve in any different ways. The logic has to match. That is it. So we are moving towards the next question, and here the question goes. A toy train travels equal distance with 3 different speeds of 3, 4 and 5 kilometer, taking rest for 2 times in between of 1.5 minute. It takes a total time of 50 minutes for the whole journey. So here is your clue. It takes 50 minutes for the whole journey, so naturally I'll go with the time reference. So let me take, this is the point where the train starts and this is the point where the train, the end of the journey. So it travels 3 equal distance. So let's say this is point A, point B, and this is point C and point D. So distance AB is equal to distance BC equal to distance CD. So that is what 3 equal distances, but the speeds are different. So here it travels a speed of 3 kilometers per hour, and here it travels a speed of 4 kilometers per hour, and the next segment it travels a speed of 5 kilometers per hour. Alright, and it takes a total time of 50 minutes by taking 1.5 minute break for two times. So let's say here it takes a 1.5 minute break, and here it takes another 1.5 minute break. So the total break is about 3 minutes. Out of 50 minutes, 3 minutes goes in for a break. So the remaining journey had taken only for a span of 47 minutes. So let me take 47 minutes. So this 47 minutes, 47 by 60. The reason why I take by 60 is I want everything to be converted in terms of hours, because I have the speeds in hours only. So 47 by 60 is nothing else but the time taken by the train to travel from distance AB, plus time taken by the train to travel distance BC, plus the time taken by the train to travel distance CD. And we know speed is distance by time, so time is distance by speed. So if we are going to take the distance as just D, so this is given by D divided by speed. Speed is 3 plus D divided by 4 plus D divided by 5 plus D divided by 5. So if I'm going to take a total LCM of 3, 4 and 5, which are co-primes to each other, so I'll go with 60. So 60 is my LCM, and this will be 20, and this will be 15, and this will be 12. So on adding I get 47 D by 60. So 47 D by 60 is 47 by 60. So it tells me that the value of D is 1. So it gives me the value of D as 1. So the distance is 1 kilometer, and the question here is what is the total distance. So 1 plus 1 plus 1 gives me 3 kilometers, and that's the answer. So here also we are going ahead with a time reference, because it is clearly mentioned that it takes a total time of 50 minutes. So here is the clue to solve the question. So 50 minutes minus 3 minutes of rest. So 47 minutes is the total time for the train to complete its journey. Moving towards the next question. So the question tells you that the distance between two cities A and B is 330 kilometer. Let me start drawing in the beginning itself. So the distance between two cities, so this is city A and this is city B. The distance between them is 330 kilometers, and let's solve this with a different color. A train starts, so this is A. A train starts from A at 8 a.m. So here it starts at 8 a.m. and travel towards B, and at 60 kilometers per hour. So the speed of this train is 60 kilometers per hour. Another train starts from B at 9. So after 1 hour, this train starts and travels with a speed of 75 kilometers per hour. At what time do they meet? See, this you can solve in different methods. One simple strategy is that this train starts at 8 o'clock and the other train starts at 9 a.m. So let me just calculate at 9 a.m. Exactly at 9 a.m. This would have traveled 60 kilometers. Okay, this would have already traveled 60 kilometers. So now the question resolves in this way. So let's say this is the distance. So this is at 9 o'clock at 9 a.m. and here also at 9 a.m. This travels at a speed of 60 kilometers per hour, and the other train travels at a speed of 75 kilometers per hour. They are moving towards each other. Okay, they are moving towards each other, and the distance between them is 330 minus 60, which will tell you 270 kilometers. So the distance between them is 270 kilometers. So at what time do they meet? So they just meet at a time 270, that is your distance divided by relative speed. Relative speed is 60 plus 75, which is 135. So 270 by 135 exactly is 2 times. So 2 hours from 9 o'clock is the time that they meet. So 9 a.m. plus 2 hours gives you 11 a.m. and that is your answer. Correct. So let me just sum up. Now the distance between them is total, in the beginning, initially it is 330 kilometers. One train starts at 8 o'clock and the other train starts at 9. So I'm going to compile at 9 o'clock the distance traveled by train A is about 60 kilometers. So now at 9 o'clock, so we are taking a scenario at 9. So at 9 the distance between them is 270 kilometers, and the time taken for them to meet is the distance divided by relative speed, which is just 2 hours from 9 a.m. is your 11 a.m. So this is one way of solving, or else you can also take the distance reference and solve. That is this, different strategies that you can use. The lesser time is what your challenge is. Moving towards the next question. a car travels for 11 hours. Out of this, it travels 100 kilometer at a certain speed, and then it increases its speed by 15 kilometers per hour to cover the remaining 280 kilometers. Find the time taken to travel the span of 280 kilometers. Let's again draw a diagram. So I'm going to use a different color now. So this is how it goes. So let's say the total time taken is 11 hours. So of course, you must be thinking that we can take the time reference. Of course, we are going to take the time reference. So 11 hours is nothing else but out of it travels 100 kilometers. So one span of distance is 100 kilometers. The other segment is 280 kilometers. So let's say this is 100 kilometers and this is another 280 kilometers. Got it? So we know speed as distance by speed is equal to distance by time taken. So your time will be equal to distance by speed. So we are directly going to take this 100 divided by speed. So I'm going to take the speed as x kilometers per hour plus 280 divided by x plus 15. Okay, x plus 15. So you must have arrived at this equation very easily. From here, the actual challenge starts. Now, if you are going to take LCM as x into x plus 15 multiplied to 80x, 100x plus 15 into 100 will be equal to 11 and manipulate, you are going to, literally kill your time. So let's take a shorter strategy from here. I am supposed to find the time taken to travel a span of 280 kilometers. So this segment is what I need to find. So the choices given here is all this segment. Let us say if I'm going to take this as my choice A, which is 5 hours. So 5 plus 6 gives me 11. 100 by anything is not going to give me 6 at all. Okay, so 5 cannot be my answer. I'll rule out this option. Let me erase this. Okay, let me erase this. I'm moving towards the next option, which is 6 hours. So of course 280 divided by 6 plus 15 cannot be 6 in any case. See, I write here 280 divided by x plus 15 can never be 6. I cannot have 6. That's not going to be my whole number. And also, if this is 6, I have to have 5. So only then I'll get 11. 100 by 5 can give me, if I'm going to take 100 by x as 5, then x has to take the value of 20. So if again this is 20, 20 plus 15 is 35. So this is no way possible. So I cannot have 6 also as my answer. I'll erase this again. So my third choice is 7. So let me just try with that. See, 280 divided by x plus 15, if this is 7. So 7 plus what gives me 11? 7 plus 4 gives me 11. 100 by x can definitely be 4. So let me take a call. So 280 divided by x plus 15 is 7. If that is 7, then x plus 15 can take the value of divided by 7. So x plus 15 can take the value of 40. Okay, so if this is 40, x is equal to 25. So if x is 25, 100 by 25 gives me 4. So this equation works well. So I confirm that 7 hours is going to be my answer. Of course, 8 is also not possible because 280 divided by 8 cannot be a whole number. And also on the other case, if this is 8, this has to be 3. So 100 by x cannot be 3. So this option can also be ruled out. So from the choice, you take the answer as 7. So this is the easiest goal. Okay, so let me again sum up. As per the question, we have drawn the equation, which is 11 is equal to 100 by x plus 280 divided by x plus 15. So if you are going to take x into x plus 15, will be your denominator is x into x plus 15. On the numerator, it gets 100 into x plus 15 plus 280 into x equal to 11. Solve, bring a quadratic equation. We would definitely kill your time because that is not the intention. So it's better to go from the choices wherein this is our target area from which we solved. We came to know that 7 option C will suit the correct answer, and that's the correct option indeed. I hope this would have given a good idea for you to solve questions based out of time and distance reference. So reading a question and deciding the reference of your question is the challenge. So if you practice a hell lot of questions, you can definitely make the correct choice out of it. That is, you will be able to point out, or you'll be able to find the strategy on which it is going to be a time reference or your distance reference. Revert for any doubts if you have, and thank you.